In this video, we are going to try one of the easiest chemistry practical experiment using my ChemLab Simulator. No, it's not QA, no, it's not titration, but instead, it is your energetics. But really, is it that simple? I think so.
Because
Reddit said so as well. According to Burning Magic from 5 years ago, he was on Reddit SG exams asking for any tips for physics or chemistry practical. After all, it's a 2-hour 30 minutes paper. It's not just you, I probably will mess it up as well. But fortunately, the kind Samaritans like Impossible Yen 4571 came out to help. And according to him, for the last 3 years, every practical experiment will consist of titration, QA, and between kinetics and your energetics. And then he went on to say, in your energetics, this is one of the easiest experiments to do. Then where will be the challenge? Good question. The challenge will come in terms of the calculation. Your Q equals to mcΔT. Whether you could calculate it effectively and also being aware of acknowledging the assumption that this thermal transfer is 100% efficient. Why else do you think we switch off all the fan? Hot no? And therefore, in today's video, I am going to show you one of the easiest experiments to do for your energetics using my ChemLab simulator so that you don't mess it up, so that you can get the perfect score, so that you can just focus on your calculation in order to score the A for your chemistry practical. But anyway, my ChemLab simulator, you don't have to off the fan, you can be in an aircon room and then you just have to sit in front of your computer. So let's go. Welcome back to another episode of my ChemLab simulator, where I'll be showcasing to you my ChemLab simulator to help students of the O-levels and A-levels prepare for their paper. And of course, this is the practical component. And these are all the stages that you'll be getting if you purchase this game as a beta tester right now. In the past 2 videos, we have showed you how to perform your QA using my ChemLab simulator and also titration. And more importantly, you were able to see how realistic they were, how they were going to help you prepare for your A-level or O-level exam. Because most of you wouldn't get enough practice for your experiment, not enough hands-on experience, and therefore that's where a lot of you will feel nervous ahead of your experiment. And that was precisely the reason why I came up with this ChemLab simulator. And today I am going to show you one of the simplest experiments to perform, and that is experiment number 5, the calorimetry. Let's get started. So you can see the bench is a bit long this time because when I got to experiment 5, I was designing for the exams ready. So in the exam stage, which I will release in a while, you will see a long bench of all 3 experiments, just like in your real exam. So let's just move to the left, and this is your setup. You can see everything on the left in your HUD is all the bottles, all your reagent, and all the instruments that you need. On the right, they're telling you how to run your different runs of experiment. Again, basic control. Tab will let you record your results. So these are all the different runs. Run 1, run 2, run 3, 4, 5, 6. Now of course you can clear. You can even clean up the bench because for this stage I didn't put in any sink yet. And then for M, you get your lab manual. So these are everything that's been given to you: concentration, the type of instruments you're given, and more importantly, what you'll be asked to calculate at the end of the experiment. Most of the time for your calorimetry, anything that involves your energy, there'll be a graph involved. For the later part where there are real prelim papers, you will have to print out the exact prelim paper where there'll be graph paper provided for you to draw on. In this case, I wanted to keep it simple because this is essentially a tutorial stages for you all to clear before you move on to your prelims. So let's get started. This experiment, one of the easiest. Essentially, you're just taking 2 big volumes of solution, mix them together, then you see how. As easy as that. And therefore, most of you would not mess this up, I hope. The mechanics in this game will be changed subsequently later on. Just a disclaimer, for those students who have tried the prelim stages, you realize that the mechanics here is way lot simpler and not as fun. But either way, I'll still show you this as a tutorial, something for you to learn. So let's have a look. So these are all the volumes set for me already. Sometimes in your exam paper they will tell you, other times you have to design it yourself. So for run 1, you need volume of 10 cm3 for Fa8, 40. And you can look through the rest first. Can you see that the total is always 50? And that's also part of the experiment design. So right now I'm going to do experiment 1. I'm going to click right here. Okay, so I'm gonna need 10 cm3 of Fa8. Now, let's go see. If I take the Fa8, you're supposed to mix it in the styrofoam cup. So for me, I think I'll put in the Fa8 as my initial solution. I'll measure the initial temperature based on Fa8. So let's look for Fa8. Probably this one. You can press number 1. you can see it's 10 cm cubed. So for all these stages, you're gonna see orange font like you did just now. It's meant as a tutorial. But when you do your prelim stages, none of these prompts will be up there anymore. You're supposed to know what is going on. So put this down. Okay, I'm gonna pick it up, number 3, pour it in. So you can see orange font again. So how to read the temperature? Press T, you can zoom in. Right, so you zoom in, you can move about. Then if you want to stir it, generally you don't stir with a thermometer, you can, but not recommended. You can always look for a stirring rod. You can press number 5, then you can press, then you stir. You can see the orange prompt, tells you that stirring. So you more or less know that this is your initial temperature. You can record it, 30, you see, done for you. Then after that you can put on your stirring rod, press number 5 again. You take this bottle, which is supposed to be, let's zoom out first. Take this bottle, which is FA9, and you can see 40 cm cube is going to go accordingly. So what I'm going to do right now is I'm going to take the measuring cylinder, and just when I add in, I'm going to look at the temperature very quickly. Okay, so press E, then you can put it down, press T. So you can see the temperature is rising very rapidly. If you want, you can take a stirring rod. Okay, you can stir. So you're going to record the highest temperature possible. Okay, so you can go on and record everything, but because of time consideration, I'd rather move on. I think you can record it on your paper as well. Especially when it comes to temperature, I think it's very important that you record it on paper instead, because it's very time sensitive. Sometimes you press the screen, it goes away, you missed out on the temperature. So for this one, I'm not going to record it, you all can record it on paper. So I'm going to put down my stirring rod. Okay, I'm going to zoom out, press T, I'm going to redo everything, right? So I'm going to press clean up my bench. I press number 2. Okay, number 2. So now the run is 15 and 35. Do the same thing again. So I'm gonna take number 1, put it in. Then take number 2, put it in. Of course, initial temperature is still 30. Generally, that's the case. Anytime when you're ready, let's go. So this one you can see temperature rising very rapidly. So during the real experiment, you need to look at the thermometer, but this one, not so. For this one, it's read for you already, 39.6. Perfect. I have a secret to share with you. For the past 2 months, I've been working hard day and night on this game, and this game is catered to the H2 chemistry students. We all know your A-levels is a highly competitive exam. It is a high-stake exam that will affect your future in terms of determining where you go from here. Whether it's NUS, NTU, SMU, or even, like my former student, Oxford. And for every component of your A-level exam, most of the time, it's about repetition, it's about the amount of effort that you put in, it's about the amount of time that you dedicated. However, one component is clearly not the same, and that component could be the biggest differentiator in terms of separating you from the B students, and that is the H2 chemistry paper for the practical exam. Because unlike every other component where you can do the papers at home, the practical component is about practicing your experiment skills, knowing exactly what to do, even though you could be shaking for your life. And in schools, you're limited in terms of how often you visit the lab, how often you get to practice the experiment, and sometimes it's just doing it once and you move on. And therefore, I have a solution. For you and my students, I have developed multiple stages of individual experiments before developing the prelim exam. Meaning, in this prelim exam module, all the experiments will be laid out for you. You will be tasked to do all 3 experiments before answering the questions, all while having the same real interaction and failure that you would experience in a real lab scenario. And that means you see color change, you see precipitate, you even see effervescence. This is as real as it can get, and nobody else out there is doing this. So if you're passionate about getting the A for your A-level H2 chemistry, and you want to be able to work on the component where most of your friends do not have access to, such that by the exam you'll be very confident walking into the hall, knowing that you probably secured about 100% of your practical component in your H2 chemistry exam, so that you have the highest chance of scoring an A for your actual A-levels. Wait no more. Sign up today and you get a lifetime subscription to the game. Now, back to the video. Okay, so 39.6. So, 6. Clean out the bench, again goes to 0, set number 3. So you can see it's just repeating this thing over and over again. So just to make sure that it works. Then after After that, you're gonna take the next one, which is number 2, pour in. You're gonna press number 3 again, pour in again. So temperature is gonna rise rapidly. You can press stirring rod, stir again. So now you see if I stir it, the temperature rise a lot more rapidly to 42.0. Again, experiment is done, write it on your paper. So, zoom out, put it on the table. I'm not going to go through all the runs. I'm going to show you that I can do all the way to the 6th run. So I'm just going to pick the 6th run. I don't even have to go in sequence. 6th run, close the tab. Again, everything have I clean up? Let's clean up again. So number 1, put it in, temperature 30, of course. Put it in. So this one number 3, ready. Let's go. So press my stirring rod. You see, once I stir, it increases a lot faster. 35.2. So you can record it on paper right now. So 35.2, if you recall just now, I think run number 3 was 40 point something, or even slightly less than that. So it suggests to you that the volume required for full neutralization is probably something like 25 and 25 cm3. Rather intuitive. Again, this is just a tutorial stage for you to get used to things. And why is it that as you add more and more in excess, the temperature increase may not be as much anymore? Because one of them is the limiting reagent, and therefore the delta H of your neutralization is more or less dependent on the limiting reagent. So this is more or less it for this. This one is one of the easiest stage for me to produce. But of course, like I said, disclaimer, this stage is just a tutorial for students and for me to get used to the game. But eventually, once I show you the prelim stages, you're gonna see how this game is gonna develop so much more dynamically, so much more gameplay, so much more realism in it. So wait no more, you know what to do. You can purchase this game via the QR code, or you can sign up as a student and you get lifetime access to all the stages every time it updates for absolutely $0. And so, nothing else. This is Yao Le from Vantage Tutor, a class above the rest. Take care.